Hello, welcome to 3.2 day one. Today we want to have a line to describe a linear relationship. And we want to figure out how we describe that using statistics. We're going to call that line a regression line. A regression line is a line that describes how a response variable y changes as the explanatory variable x changes. We often use the regression to predict the value of y for a given value of x. The prediction value is denoted as y hat. And we call it that because we put a little hat on y. The true value is denoted as y. So there's going to be some error or residual between these two. And what we do is we take our actual y and subtract our predicted y. And our predicted y is what we get from our equation. Our equation we generally call the least squares regression line. It's a line of best fit where the sum of the squares of the residuals is the smallest, or the least. So the equation of the least squares regression line is y hat is equal to a plus bx, where y hat is our predicted value for y. It's very important that you have a little hat on here. And we can find the slope if we know the r and the standard deviation of y over x, because the slope is equal to r times standard deviation y over standard deviation x. And another important feature of this line is that this line, it will always pass through the point x mean, y mean. So if you find the mean of the x's and the mean of the y's, see where those intersect, that will be one point on our least squares regression line. So let's take an example. Because elderly people have a difficulty standing to have their heights measured, a study looked at predicting overall height from the length from knowing the height to the knee. Here are some examples of 5 elderly men. So this is their knee height, and this is their total height, and this is in centimeters. So we want to construct a scatter plot. Well, we're going to try to predict the height. So that's going to be our response variable. And our explanatory variable is going to be knee height. Now what we want to do is figure out a good scale. This goes from about 40 to 60. So we're going to go from about 40 to 60 here. And in the y values, they're going to go from 140 all the way up to, let's just go up to, say, 190. This goes a little past 190 to 192. All right. So we can take these and try to plot these points on the graph. Pause the video and see how you do. Here are our values. For some reason, that one went down. So this slide I had 192, but I somehow turned to 189. So hopefully you have 189 in there instead of, but the only difference is this would just be a little higher. Maybe I moved it down to actually fit nicely in my graph. All right, so here are our values. And that's our scatter plot. Make sure that both axes are labeled. Make sure that they're scaled appropriately. Here, this goes up by 5. These go up by 10. All right, now we want to find and interpret the correlation coefficient in the context of this problem. So to find that correlation coefficient, we hit Stat, Edit, and you plug in your values for L1 and L2. When you're done with that, now we're going to hit Stat again, go to Calc. Now there's 2 linear regressions. There's number 4, and then there is number 8. See how number 8 is a plus bx? It's going to, and number 4 was ax plus b. This is just a little bit better because this is what you're used to seeing as b being the slope. But either way, you'd get the same data. Just you have to pay attention to what your variables are. So this is what we get out of our calculator. So our R value is 0.862998 and so on. So we'll say there is a strong positive linear correlation between knee height and total height. Now when we are grading this, the things we're looking for is you talk about its strength, its direction being positive or negative, its form being linear, and that you have some sort of context for this problem. Now use your calculator to determine your least squares regression line. Now that's exactly what the rest of this is. Y equals a plus bx. So instead of y, this is our y hat. And it's pretty important that we have y hat so we know that it's predicted values. Y hat is equal to 48.11 plus our b of 2.34x. Now we have to define any variables that we use. So our x is going to be the knee height, where our y hat is our predicted total height. Now keep in mind, though, we need the word predicted because we don't get the total height when it comes out. We get the predicted total height. All right, so now we want to draw the line of best fit on our graph. So if we go back up to our graph and we try to draw this, we need to pick two values. So I'm going to come down here and I'm going to maybe put in a 45 for x. So y hat is going to be 48.11 plus 2.34 times 45. And then I'm going to do the same thing with a higher number, say 60. Let's see what we get. All right, for 45, I plugged these into my calculator and I got 153.51. And for 60, I got 188.51. So if I go up here, oops, let's do the graph that actually has something on it. If I go up to 45, I'm going to go up to 153. So there's 150, 153 is about there. And if I go up to 60, I'm going to go up to 188, which is about there. So now I draw my least squares regression line, starting up there. I drew it a little above, so there we go. Notice how it doesn't pass through here, and I don't want it to pass through there. It's possible that it does, but our main concern is that it passes through these points. All right, so now we drew our line of best fit. Now we want to interpret the slope and y-intercept. Remember, our slope was 2.34, so we want to say something about for every increase in 1 centimeter of knee height, the total height increases 2.34 centimeters. Now for slope, or for y-intercept, our y-intercept is 48.11. So we'd say if knee height equals 0, then total height will be 48.11 centimeters. Now, And you can also make a statement after this talking about how that's pretty ridiculous, because if someone's knee height is 0, they have a problem. They're, whether their leg is cut off um, or something, because they won't actually have a total height of 48.11, or um, that's not a very good predictor at that place. Now, one thing we wanted to state is the distinction between explanatory and response variables is essential. So if I switch the knee height and the height, if I switch these two variables, I'm going to get a completely different line, completely different y-intercept, a different slope. So it's important that we correctly choose our explanatory and response variables. Now let's look at extrapolation. Now extrapolation is the use of a regression line for prediction outside of the range of values of explanatory variable x used to obtain the line. Such predictions are often inaccurate. Just like we were just talking about the y-intercept on the previous problem, was that was outside of the values that we had. So if we continue that line all the way to the y-axis, it's not accurate anymore. So extrapolation, sometimes we have to do it, but if it's outside of the values that we have, it tends to be less accurate. So let's use extrapolation to show the height of an elderly person if we know their knee length is 65. So we just put it in our equation. If my computer will work, 2.34 times 65 plus 48.11. And if I type that in, I would get 200.21 for a total height. All right. Now, if one man had a knee height of 55.2 centimeters, I don't know why this says years, and an overall height of 169.1, let's circle that point on the scatter plot and then draw a segment on the scatter plot that corresponds to the residual, and then find that residual. So let's go up to our scatter plot. And that point, 55.2, 169, is right here. So the residual is this red line going up to it. Now that residual I can find by taking y minus y hat. Now my y value is 169.1. My y hat value I get by plugging in this into the function. So I would say 2.34 times 55.2, and then I add on to 48.11. If I do that, I get the value 177.3 about. So that's my predicted y value, which is up here, 177.3. Now when I subtract them, I get this length, which we call our residual, which is about negative 8.2. Now, whenever a residual is below the line, it's going to have a negative number. Or whenever a point is below the line, the residual will be negative. If the point is above our line, then that residual will be positive. All right, that's all we have for today. I hope this helps in doing your homework. Good luck.